Balloons ubiquitous in celebrations and decorations. Come in various shapes, sizes, and colors. In earlier days, balloons were made of dried animal bladders. Imagine those at a party or celebration. That didn't stay the norm though. In the 19th century, someone finally came up with rubber balloons, and those were eventually replaced too with latex, since latex is incredibly elastic and can stretch up to 7 to 8 times its size. There was merit to using it as a material. Now the balloon industry is valued at $300 million USD. But how are they made? Raw natural latex is a white or yellowish opaque liquid, similar in appearance to milk. Latex is the secretion of certain plants, in particular the hevea tree, originally found in Brazil. The most important sources of natural rubber today are plantations in Malaysia and Africa. Producers of rubber must harvest the raw material from these trees. Skilled workers, often called tappers, make incisions in the bark of the rubber trees using special tapping knives. These incisions allow the milky, white latex sap to flow out of the tree and into collection cups attached to the trees. The latex sap, which resembles milk in appearance, gradually fills the collection cups over several hours. Tappers visit the trees periodically to collect the latex, typically every 1 to 3 days, depending on factors like tree health and climate. Once collected, the latex undergoes treatment to prevent coagulation, which would render it unsuitable for further processing. Ammonia is commonly added to the latex as a preservative, maintaining its fluidity. During storage and transportation, various additives are mixed into the latex to improve its properties and performance. In balloon production, antioxidants help prevent degradation of the latex due to exposure to RN light. Vulcanizing agents are added to promote cross-linking of polymer chains during curing, enhancing elasticity and durability. The latex undergoes a concentration process to remove excess water and increase the concentration of rubber particles. This can be achieved through centrifugation, where the latex is spun at high speeds to separate solids from liquids, or evaporation, where heat is applied to remove water. Then, the latex is transported from production facilities to balloon manufacturing plants using specialized containers or tanker trucks. During transportation, care is taken to prevent exposure to extreme temperatures or mechanical damage, which could compromise the quality of the latex. At the factory, the latex is mixed with dye and filtered through cheesecloth to prevent any lumps. Agitators at the bottom of the tank mix it up for 15 hours. This not only distributes the color, but also keeps the latex active, which would otherwise become congeal. This factory produces balloons, and as many as 53 different colors. The molds used to shape round balloons in a factory look like neatly arranged, upright baby rattles traveling on a tray. They might be set out in a grid of, say, 3 rows of 11 molds each. This tray of molds will roll from station to station, some of which contain special fixtures to flip the tray, so it can be dipped into various chemicals. However, before any of this, the balloon forms, or molds, are sprayed with hot water to clean them. As they pass through a system of rollers, these forms are then flipped and dipped into a tank of coagulant. The coagulant also contains an electrochemical charge. When the balloon forms with a coagulant interact with the tank containing the colored latex, they attract the latex solution, resulting in a thin, uniform coating over the balloon mold. The longer the forms are left in the tank, the thicker the coating that sticks to them. For balloons, a very thin layer of latex is desired, so the forms are immersed only for a few seconds. The forms must be inserted and removed at carefully controlled speeds to avoid trapping air bubbles and to achieve an even thin coating. The balloon forms are then moved on a conveyor towards spiraling brushes. These brushes roll up the bottom of the balloons, creating lips. These grips make it easier for people to grip the balloons and inflate them. The balloon forms are then dipped into a hot water bath. This step is important because it cleans the latex, including getting rid of the protein that causes latex allergies. The hot water also triggers vulcanization, which rubberizes the latex. This process, discovered completely by accident by Charles Goodyear, revolutionized the rubber industry. It significantly enhances the elasticity and durability of rubber. Before vulcanization, raw rubber is relatively soft. sticky, and prone to deformation and degradation under various conditions. After vulcanization, rubber becomes more resilient and can withstand greater stress, making it suitable for a wide range of applications. The next step is to strip the balloons from the molds. To make the process easier, the forms are dipped into a mix of talcum powder in water. This will allow them to be seamlessly stripped. Off the form. Finally, it's time for the forms to be stripped of their latex coverings as the forms pass through this machine. Air jets fill the balloons with air. As the balloons fill with air and start to come out of the form, they're grabbed by rollers at the top that roll them away from the forms. The stripped balloons then topple onto a conveyor belt. They're received by a worker who piles them onto an industrial washing machine and then adds a cleaning solution. The machine heats to 71 degrees Celsius. This process not only cleans the balloons, but also completes the vulcanization of the latex. Balloons undergo pressure testing to ensure they can withstand inflation without bursting. This involves inflating balloons to their maximum capacity and subjecting them to specified pressures for a predetermined duration. Quality control measures also include assessing color consistency across batches to meet customer expectations. The balloon manufacturing environment itself must be strictly controlled in order to achieve high quality and consistency. Throughout the manufacturing process, computer-based instrumentation records and controls air humidity, air temperature, latex tank temperature, the temperature in the oven, dryers, and other parameters. The latex and other chemicals used in the process must be carefully formulated for specific properties and carefully maintained. For example, the latex must have a certain viscosity and speed of drying. The tanks in which it is held must have devices to keep the latex circulating to avoid forming a skin and to prevent ingredients from settling. After passing quality control checks, balloons are grouped, unpackaged according to customer requirements. Packaging may involve individual wrapping or bunging balloons together. Packaged balloons are stored in controlled environments to maintain their integrity. Careful handling during transportation prevents damage and deformation. The next time you're at a party and spot a balloon, you can truly appreciate the amount of work that goes into making one. If you like this video and want to watch more, check out our channel.